This is Lab 1 by Ben Melville. So in this lab, we will study the interaction between charged objects using tape. In using the tape, we will create a temporarily unequal charge on each piece of tape and compare the interactions of the tape with the environment around us. We will also use the tape to compare the gravitational force to the Coulomb force and model our findings in GlowScript. So this is my initial setup. I had one piece of tape on the desk and then two pieces of tape hanging from my desk. I used the tape hanging from my desk to, I put it right on top of the tape that's on my desk and then ripped it off very quickly to get an excess charge on either the tape on my desk or the tape that I was holding. And I brought it near a neutral object, such as my desk or a textbook. I brought it near both, and it was attracted to it, which makes sense because anything with an excess charge is attracted to neutral objects. So that was a good sign that the tape was charged. And then I charged up a plastic pen by rubbing it with a piece of cloth, and which made the pen have an excess negative charge. And then I brought my tape near it, and it turns out that the tape was attracted to it. So that means that my tape actually lost charge to the tape on my desk, meaning my tape was positively charged. And an interesting observation would be that if the electrons had positive charge and then the protons had negative charge, if the two were basically flipped, then all the interactions would be opposite except for those in which there's a neutral charge involved, because the tape would be attracted to the neutral charge no matter what. If the tape was negatively charged, it would still be attracted to my desk. If it was positively charged, attracted to my desk. And I found it was important to touch the tapes as little as possible, because the more you touch the tapes, the more charge on the tape is going to want to ground through your hand, and it'll just make your results less effective. So these are some of the fundamental principles involved. Really the only two that we're dealing with. It's the electric force, which the tapes were feeling in between each other. In this experiment, again, like with the two pieces of tape that were hanging, ended up putting one piece of tape in between two books, and then using the other tape to act as a force upward on that piece of tape to get it to levitate almost above the books. And so the force going up on that would be the electric force, and then the force coming down would be the gravitational force. So here's some of the data and measurements I came up with. I found the force of gravity beyond the tape to be equal to 1.962 times 10 to the negative 3 newtons. And I set that equal to the electric force because the two were offsetting each other to have zero net force, as you can see on the free body diagram on the right. And ultimately found the charge on the tape to be 6.069 times 10 to the negative 9 coulombs. You can see the work there. And then found the number of electrons to be equal to the charge on the tape divided by the charge of an electron, which was 3.79 times 10 to the 10 electrons. And then use that number to try and find the number of electrons per atom. There's a lot of assumptions involved in this, such as like the surface area of the tape, having evenly distributed atoms, and then the atoms are not cube. I assume that they're cubes in this, but they're not, they're spheres. And anyway, found it to be 9.484 times 10 to the negative 8 electrons per atom. The model here shows the gravitational force and electric force each tape is feeling. I've represented the tapes as spheres, and as you can see, it's very similar to the free body diagram, as it has the electric force going up and the gravitational force going down, and they are both equal. Here are some of the lab questions that we were asked to answer throughout the lab. I will not go through all of these, but I hope you pause the video and take some time to review my answers. And that is all. I hope you enjoyed the video, and thank you very much.